Okay, so thanks a lot for joining today's webinar on real-time data. This is a webinar which we are conducting as part of the data.europa.eu Academy. And within this webinar, we would like to tell you a bit about activities regarding real-time data as part of data.europa.eu. Also give a general overview on this topic of real-time data, and also perhaps see in a later discussion, depending how much time we will have, gathering also some feedback on your experiences with real-time data, and also learning perhaps a bit more what you would perhaps expect from data.europa.eu to facilitate the discovery of real-time data sources for your daily work or for the publication of such types of data sources. So for this purpose, we will have a look at what is real-time data, give a quick introduction into this. We will look at some application examples showing the value of real-time data for different application domains. Then we have selected two relevant technologies, the OGC Sensor Things API, which is also Inspire good practice, and MQTT, which is a protocol from especially also the Internet of Things world, which help to facilitate the publication of real-time data. And then we will close with our discussion activities. So just as a quick introduction, who we are. First, I would like to hand over to Antje, who is supporting me in this activity.
Thank you, Simon. My name is Antje Kügler. I work for Conterra, a company based in Münster, Germany. And at Conterra, we focus on integrating geoinformation into our customers' workflows and IT structures. And together with 52 North, we have a joint team working on data.europa.eu. And we are responsible for the geospatial dimension of the portal. And that includes 4 technical topics. The first one is the GeoHarvester, which is used to harvest metadata from geoportals into data.europa.eu. Then we have a gazetteer backend to find a location. Then we have the geovisualization, which is putting the geodata on the map, and handling real-time data, which often has a geospatial dimension, and this is what we're doing the webinar on.
Okay, thank you very much, Antje. I would also like to introduce myself. So my name is Simon Jöcker. I'm working at 52 North. This is a small research and development oriented company based in Germany, in Münster. And our focus is to work on applied research on advancing spatial information infrastructure concepts. And as part of this work, I've been involved in several projects and activities dealing with real-time and sensor data, also investigating how such data can be used and shared according to interoperability standards, also linking, for example, to the Inspire Directive. And with this background, I'm also working in the data.europa.eu project in order to facilitate and trying to advance the handling of real-time data as an open data source via the data.europa.eu portal. So to just introduce a bit how we will conduct this webinar. So the training will be recorded. In order to make this as smooth as possible, it would be great if you could make sure that you are muted during the training session. At the end, we will ask you a short feedback form. Wouldn't take long, but would help us to improve also for the future. And for questions, we are using Slidesoo, which allows you to send your questions and answers. And we will also use this for discussing certain topics which we will directly ask you. So if you would like to use this and would like to work with this, please go to sli.do, as sli.do. You can type this as a URL into your browser, and then you can enter the event code real-time. So I will perhaps just quickly show this, how this works. So we are going to Slidesoo, and then we can enter as a participant real time, and then you will be able to answer to polls which we will open, and if you click on Q&A, you will be able to ask questions about the presentation, which we will try to answer either in between or collectively at the end of the session. So that's some of the basics, how we would like to organize this. And with that, I would shortly like to hand over to Antje for quickly introducing a bit of the background on data.europa.eu, so the big project, which is also leading our activities here on real-time data.
Yes, data.europa.eu provides access to open data, and it's meant as a single point of access to data in Europe. And this is done with metadata. Metadata, you might know, is data about data. So it's a description of the data that can be found. And data.europa.eu includes metadata, which will usually point to the data, which is then stored in its original place. So it's not stored in data.europa.eu itself. Usually it just points to data and gives this description. But data.europa.eu is going beyond collecting metadata. The strategic objective is to improve accessibility and the value of open data. Could you move to the next slide? Yes, thank you. Currently, data.europa.eu has 173 catalogs, and from these catalogs, it harvests metadata. Catalogs are either, they can be seen as individual data sources for either open data or geoportal. And depending on how the countries are organized, they usually have one or more catalogs which are being harvested. It's often one national open data portal and one national geoportal, but it could also be other portals that are being harvested. And on top of these national catalogs and probably regional or even local catalogs, there are also international catalogs from EU institutions or also international organizations that are being harvested. For example, the International Council for the Exploration of the Sea. That would be one example of such an international catalog. I think that should be enough for a brief introduction.
Okay, thank you very much, Antje. And with that, I would like to get into the topic of real-time data. So what are the objectives which we would like to talk about today? We would like to illustrate the current status of real-time data in data.europa.eu. So there are some examples already available. However, that's something which we expect will get further and more importance in the future. Besides that, we would like to provide also an overview of relevant standards, APIs, technologies. So we will not dive into too much of the technical details, but we would just like to quickly introduce you what is there already and what could be reused. And if you are interested, then we would also be able to give you further guidance how to dive deeper into these concepts and ideas and technologies. And then finally, we would like to gather also feedback. So, for example, which types of real-time data sources should be further investigated for data.europa.eu? Are there certain APIs, API standards which are relevant for us or which you would like to recommend? And also to see and use this as input for our future directions and prioritize perhaps certain work items there. So let's start with the basic question, what do we consider as real-time data? So It's quite put simple. Somehow you could say it's basically data that is immediately delivered after it has been collected. So for example, if you have a sensor somewhere out there, it measures a temperature, then you get this temperature immediately delivered to you onto your computer screen or into some kind of dashboard, whatever. So real-time data is often important for some kinds of live decision-making. So you may think of dashboards showing the current traffic situation in a city. You can also do real-time data analytics. For example, you may continuously analyze air quality parameters concerning critical pollutant concentrations. You may monitor water level data, perhaps combine this with weather data, and then try to derive information and live decision-making from this information. And however, openly accessible real-time data streams are still rare. So there are some available and there's an increasing number becoming available. But in many cases, such data streams are not yet open. Mainly they are used for internal purposes, but it's still a very valuable type of data. And we would like to promote also the sharing of such real-time data as part of data.europa.eu. So what are typical examples of real-time data? So that could be traffic information like traffic flow, information about traffic congestion, traffic density, traffic lights, weather measurements, that's quite obvious. So weather stations across Europe are delivering huge amounts of data, important for many decisions. Rain radar, something many of you may are already using from your browser when checking if you go out for a walk, if there's rain coming or not. Water level measurements, that's a very broadly used example for managing river discharge, flood monitoring, etc. But there are also other types of information like people flow in cities. So there are some cities who have established an automatic counting system to determine how many people are moving along the streets, especially in the shopping areas. Or other types of real-time information, maybe gasoline prices, which help you to decide if you are going to buy gasoline for your car or which is perhaps the cheapest location where you can buy something. So also all these are different types of real-time information, and this is data which is useful in many applications. So if we look at this typical data types which we are dealing with, that may be, for example, tracking data. Tracking is quite obvious. So you may track the location of the fleet of cars of a company, but you may also track parcels which are shipped with couriers. You may also think about data measured at stationary locations, that the typical sensor station, for example, for the weather station, but you may also measure data along trajectories. So on the right-hand side here, you have an example of data measured by a vessel traveling across the North Sea along the Norwegian coast further up. And there you can also measure different parameters like salinity of the water along a trajectory. Other types of real-time data may be image data, financial data. So a very broad range of real-time information, which is important for users out there. Then also because of this high value, and that's also a motivation for our work here, if we look at the Open Data Directive, so the Directive on Open Data and the reuse of public sector information, they have a statement in there saying for dynamic data, meaning frequently updated data, often in real time, public sector bodies and public undertakings should make this available for reuse immediately after collection by ways of suitable APIs where relevant as bulk download, save for cases where this would impose disproportionate effort. So that's basically the statement from the Open Data Directive underlining the relevance of such real-time data streams and making this easily available via APIs. And within this webinar, we would like to show a few examples where organizations are already sharing such real-time data. And in the end, we will also look at two technologies which have been proven already as suitable approaches for sharing such data. However, this will not be a limiting list. These are just suggestions which we also have observed in practice. So before we go now into the next part, I would like to just motivate or ask you to go to Slidesoo to answer one first question. So the question is, for which purposes do you currently use real-time data? So some of you may not already use real-time data, but those of you who are using real-time data, it would be great to learn a bit in which contexts you are doing this. So for answering this, you can go to Slidesoo, and if you have opened Slidesoo, you can go to the poll section, and there you have a text field where you can enter your information, and if you click on send, this will be registered and recorded as feedback here for the meeting. So let's check. So we already getting some inputs here. So we are seeing rain traffic information, public transportation. I didn't mention that, but that's also a very important aspect. Weather forecast, bus connections, stock market. Yes, that's also a very big field. Flood warning, traffic, GPS, so tracking data, that's very important. Yeah, so I think that is already a very good overview. So more is coming, so thanks a lot for this. But we see already some patterns like flood warning. Public transport is a very big thing, what I can see here, air pollution. And this also relates quite well to some of the examples we will look at now within the next minutes. Okay, so thanks a lot for this. And I would suggest to move ahead. And we are going now a bit more into a few application examples to illustrate in which cases, for example, real-time data is already used or also available for working with it. And here I've taken up a few things which were also mentioned in the feedback here. So traffic information, warning and monitoring of natural hazards, for example, flood information, water level information, and also air quality information. So let's look at the first example that I've selected here. And this example is something which is already available on data.europa.eu. And in this context, we are linking to a component developed as part of the Fireware initiative, also supported by the European Commission. And this includes, for example, here on data.europa.eu, tracking data about buses, parking space availability. So these are typical data models for which Fireware offers data models, well-defined data models. And this information is then shared via a component, the so-called Fireware context broker. And this basically then provides an interface which helps to access different Internet of Things devices or sensors or information coming from other computer systems like a bus tracking system of a public transportation company. This can be then interfaced via the context broker to the Internet so that it can be reused by other applications. And if you are interested in this, there's a very comprehensive collection of data models available on GitHub, which you can have a closer look at if you like. So we will not go into depth here, but just to introduce here, there's this Fireware context broker component, which helps to access real-time data from different domains using well-defined data models. And on the next slide, these are a couple of links, so we will share the slides after the meeting also with you. I will just quickly demonstrate what's available there. So we have a certain set of data available here on data.europa.eu. Here, two data set examples in an example catalog, which we are hosting there. One is, for example, bus locations in real time. And if we open up this data set, we will get a preview of the available data. So in the background, there is basically for those of you who are a bit more into the technical details, I can quickly show this. So basically we get JSON encoded information here. So for those who are in web development, that's quite useful information, quite efficient. And you can see here we have information about a bus, specific vehicle type, the current location of the bus, the line number, and an identifier of the vehicle. And then we can put it on such a map, which then shows the current locations of buses. This is data from Malaga. And this information then can be used for tracking, for example, the buses in public transportation. In 2 seconds, 1 second, we will get a refresh and you see these points have moved. So here we are polling the endpoint, this API in the background in order to get up-to-date bus locations. Here we have a refresh rate of 1 minute, and we can use this then to get anytime the latest bus information. And basically this feature which you see here, it's intended as a exploration option. So if you find such a real-time data set on data.europa.eu, you can use this geospatial viewer as a preview of the data. So it's not intended as a final exploration tool, but should be useful for exploring what such a real-time data set contains. So then I will go to the next data set which is available. This is, for example, it works in a similar way. This is parking space information. So here are different parking spaces, and we get in real time the information how many available parking spots are available at the different parking locations. So also this is some kind of real-time data. So for example, if you are traveling into the city, you can use this information to decide where to best go in order to find or have a good chance of finding a parking space. So these are two examples which are already available on data.europa.eu. There has been some activity in previous projects. For example, as part of the European Data Portal back then, there was a cooperation with the developers of this Fireware context broker in order to support the creation of corresponding metadata and making it easier to register such data in data.europa.eu. So this is still also some work in progress in the sense that we just have a few example data sets here available. However, for the future, we hope with this integration options and the creation of corresponding metadata, we will get more inputs and more available data sets, which we then also can highlight here and showcase as part of this preview functionality. So this is just the backup slides with screenshots. Then I would like to go to another example application. This is a scenario where we are dealing with monitoring of hydrological parameters, flooding situations. And for this purpose, there are many organizations in hydrology which are collecting large amounts of real-time data. So that may be federal agencies, regional agencies managing the water in local areas. And this has different purposes. So on the one hand, of course, flood monitoring, that's a very important thing. But other aspects are, for example, water management. So making sure that the industry has sufficient cooling water available from rivers, or even going to scenarios like recreation. Recreation, basically, if you would like to go with a boat on a small river with real-time data about the water level, you can determine if it makes sense to go to the river, if there's enough water in it in order to go boating on that specific river. So such information has many use cases. And also there, I would like to go to one example. And this example is coming from the Wupperverband. The Wupperverband is a regional water management authority here in Germany, in the area of the Wupper River. And they are operating a so-called sensor web infrastructure. So they are using slightly different standards, and they are publishing this also using Inspire compliant web service interfaces. And there you can then also go to their website and explore the available data sets. So for example, you get an overview about the available measurement stations. So in this case, we are talking about stationary data measured at fixed locations. And then we can view these stations and see. So for example, here we have the latest data from today, 9:50. That is rainfall data. And then you can also explore the data as a diagram. So for example, let me add, for example, on the one hand, the rainfall. Let's take this one. So that's up-to-date data. And then in order to see this in combination with other relevant parameters, so for example, we can take water level information. And what you can see here now is you have a time series view of these data. So typically in real time, we are on the one hand thinking about having the latest measurement available. However, often you will also want to look in the history of the data in order to discover trends and see how things have changed. And here, for example, you can see these bar chart. This is rainfall. I think rainfall amount within 5 minutes. And you can see here you have this bar chart. That means there has been rainfall coming down, and this has resulted then in increasing water level. So with this, you can easily visually correlate different parameters, in this case, rainfall and water level development, by having a look at such data sources dedicated to sensor data streams. So let's go back to the presentation. And the last example that I would like to talk about is air quality information. That was also mentioned as one of the answers given by you on Slidesoo. And here, air quality data, again, is collected across Europe by many agencies. There are also citizen science projects working on this, also activities. For example, I'm aware that the JRC has also been working on a project where they are using or evaluating different types of sensors regarding the accuracy and trying to densify the official public measurement networks with further sensors in order to get a better coverage of data, and at the same time having a clear view on the data quality of perhaps medium cost sensors and how they can be then used in order to get a better impression of air quality situation. And what also has to be mentioned, there are already interesting reporting data workflows available. So for example, the European Environment Agency, the EEA, collects from all its member states near up-to-date e-reporting data on air quality measurements, so-called Flow E2A, for those who are perhaps a bit more into this topic. And this is data which is not in the sense of classical real time with a delay of a few seconds, but still it's up-to-date data from the same day usually, which also gives you a good indication of the air quality situation. And some of the member states of the European Union are already providing access also to near live data using different types of interfaces. And here's one example that was developed in cooperation with the JRC as part of the ActiveSense project. I will also try to show this live. So here we have connected to a web service endpoint delivering data from different cities in Europe, mainly Oslo, Zagreb, and Antwerp in Belgium. And here we have then again an overview of the available measurement stations. And in preparation of this, I've already connected two stations in Antwerp, for example, one delivering information about black carbon measurements, the other one about nitrogen dioxide. And also here we have quite up-to-date data available, which we then can explore on such a diagram view. But also here again, the interesting thing is we can get real-time information about air quality already from several sources. The discoverability, however, and the provision under open data licenses, that's something which is not yet so complete across Europe. Okay, so that's the view on a few application examples. And before going into the technologies, I would like to quickly check if there are any questions already coming from the chat.
Yes, Simon, there are two questions. The first one is it possible in data.europa.eu to display in the same map the buses and car park of Malaga? Those were two different data sets that you showed.
So at the moment, that is not yet possible because they are registered as different data sets. And in data.europa.eu, our scope until now is just to provide a preview of the data sets so that users can discover these data sets and then perhaps do a quick assessment of the data via the portal and then use the resources provided by the portal, especially the links, and as part of other applications. But indeed, it may be something worth considering for the future. So perhaps something we need to check further and discuss.
Actually received 2 likes, so that might be something to investigate. There's a second question. I'll read it out. Did I understand it correctly that you sometimes work directly together with data providers to improve the data and metadata they deliver to data.europa.eu? Yeah, it's a 2-part question, so.
So perhaps I can answer one part here regarding, so as part of what we have shown for the Fireware data context broker, there it was a cooperation with a tool provider. So the developers of the context broker who they are then on their own supporting data providers in making their data available, but we help them to develop extensions to make it easier to integrate the data in data.europa.eu. But besides this, there are also other activities in data.europa.eu where we want to help data providers to facilitate the data publication process. And I think also in some cases, there is also the exchange with data providers giving feedback on metadata, for example.
Yes, that would be the second part of the question. It says, if yes, how often does this happen? And can you give a few examples?
So that's perhaps something, I'm not sure, Laura, if you are available, perhaps you have a better overview on this.
Actually, it might be myself, because Conterra is responsible for the geo-harvester. So the harvesting of the metadata, it basically has there are two parts. One is the general harvesting, and then we have which harvests open data portals, and then we have the geo harvester, which is like a special component to to harvest metadata from geo portals and map them into the metadata format used on data.europa.eu. And for the geo portals, we usually have contact with the geoportal providers when they ask to be harvested, because then we check the metadata and see if there are any problems with it, and if there is, we would get in contact and discuss this, and then if problems occur. So it's not a regular thing, but if either we notice that something has changed in the metadata that would require action, or if the portal providers approach us, but it's not that often. Hope that answers the question. And Simon, there are actually more questions here. There's one, are there applications that call the data directly from data.europa.eu? And if so, can you give a few examples?
So here it's so that data.europa.eu does not provide the data directly. So we are just providing the links to the data access for these real-time data sources. So for now, there are, I think, also other activities for supporting data publication, but for the real-time data, we are not hosting the data ourselves. We are instead redirecting or providing links to the authorities having the correct data available immediately.
And then there's one more question. Have you considered the implications on critical infrastructure? Should, for example, the bus locations be obfuscated due to possible terrorist attacks? What's your stance on that? What are data providers doing? Best practices?
Mm-hmm. So I think here at data.europa.eu, we are basically taking data that has been officially published by the data provider. So the assessment if a certain data set can be published or not is something which is done typically by the data provider. Also, if you look, for example, at the hydrological data, so this is also quite sometimes sensitive information. If you also there look at river dams, etc., and also there in this case, which I have shown, the data provider basically has decided we can publish certain types of data which are of relevance to the public, which are not critical, and at the same time, certain critical data is then has been decided by the publisher not to be put to the outside. So typically, also the data providers have the best knowledge if a certain data set is critical or not. And of course, that's something which is also something where we could help with discussion, but there the approach would be to trust also in the data provider to check what should be published and what not.
We have one more question on Slidesoo, and that's which are the current agreements to increase discoverability of real-time data within data.europa.eu, such as use of keywords, vocabularies?
That's indeed something where we need to further work on. So we have identified here a set of issues which need to be addressed in the future in order to improve this. One example is if you are accessing many data sets which contain real-time data, they are just described as some kind of JSON data set. So a typically encoded set of data, and there we indeed would need to further improve this. Better guidance and better mechanisms to indicate that indicate in the metadata certain data types that let us know, okay, this is a real-time data set and this needs to be improved, because then it would also be easier for us to recognize these data sets and, for example, offer a preview visualization and continue with that. But this is, I think, one of the big work items in order to make it better to discover real-time data via data.europa.eu. So it's a very, very good question, but it needs further work.
Yeah, I think this is it for the questions right now.
Okay, then I would continue with a quick view on a couple of selected technologies. So I'm aware that this webinar is not intended as a deep dive into technological issues. However, I would like to just quickly introduce two of them, but staying a bit more high level. And if you are interested to learn more about these and perhaps also how to apply this in order to share your own geospatial data, that's something where we would also be happy to talk with you as a follow-up to this webinar. So there also, if we can do some further exchange there, we would be really happy to get in contact with you. Perhaps one important thing that we need to consider is interoperability. So if you look at many types of data sources available on data.europa.eu, these data sets are following certain standards. And also for real-time data, standardization is, at least to a certain extent, important. And perhaps let me illustrate this with this image. So on the upper side here, we have three data consumers: a geospatial information system, a web client, and a desktop system. And then we have three observation networks delivering data, but they are all talking their own language. They have their own data models, their own encodings. And if we would like to consume the data from these data providers, we would have to consume each data consumer to the specific data models and interfaces used by these different observation networks. If we add more observation networks, we have to add more custom solutions to link to these observation networks. And the more data consumers we add, we also get increasing overhead in order to implement specific connectors to all these different observation networks. And in the end, this will not scale. And for addressing this, the idea is to go for standards. And here I've selected two, the OGC Standard Things API and MQTT, in order to share geospatial or to share real-time data, in this case real-time data, in a common way and limit the integration effort necessary to connect to these data sources. So these standards make it basically easier to reuse existing geospatial data, real-time data sources, and then broaden also the usability of this. The first standard I would like to talk about is the OGC Standard Things API. For those of you working with geospatial data, you may have heard about other standards of the OGC, the Open Geospatial Consortium. So, for example, they have developed also specifications for accessing maps, the web map service, for feature data, etc. And one addition of these, the suite of standards, is the so-called OGC Standard Things API. And basically, this API is a specification which defines an approach how to access real-time sensor observations in a lightweight and efficient manner. And for this purpose, the Sensors Things API standard defines, on the one hand, a data model for observation data and data streams. So it tells you basically which information do I need in order to encode my data so that the user can understand the observation, the measurement data. And on the other hand, based on this data model, there's a REST interface for creating, reading, updating, and deleting observation data. So it's basically a specification that defines you how to encode your data and how to get this data downloaded from a server into your application. Here is just a quick overview of this data model. So I do not want to scare you away with all this UML stuff here, but what I would like to show you is the main concepts that we have in here. So, for example, we are organizing our data as so-called data streams, and a data stream is basically a set of data coming from a sensor. This data has a certain unit of measurement, for example. It has a time span in which the data set has been observed. We have so-called observed property. Basically, that's the parameter that we are measuring. So we need to describe in every sensor measurement that we are measuring temperature, we are measuring water level. So this phenomenon, this property which we are measuring needs to be described. We need to refer to the sensor which has done the measurement. We need to provide, in many cases, also a geospatial location. This is called here feature of interest. And then, of course, we need to provide certain timestamps and, of course, the observed value. So, like it's currently 5 degrees centigrade here in Münster. So this data model, what you should learn from this is there is a formally specified data model, and this data model basically describes all the important elements that you have to make sure is available in your data in order to make it reusable by client applications so that it can be interpreted. So that's the purpose of the Sensor Things API. And on top of this data model, it provides an encoding how the data should be encoded as a JSON file. So a typical broadly used data format in building information infrastructures, and how to query such data using a REST API. And what's important to note is this OGC Sensor Things API specification has been also endorsed as an Inspire good practice. That means you can implement, for example, Inspire download services relying on the standard. And quickly looking at what's behind this, here I'm connecting to an example server that we are operating here at 52 North. You get if you connect to the server, you get different types of resources that you can access. For example, data streams. Data streams is basically something like a data set. And then we have here, for example, data from Oslo. We have a name for our data set. We have a data stream description. We are providing the unit of measurement. We are providing information about the time span when this data has been measured. We have the observed property, which is basically the parameter which we are observing. And we can also refer to the individual observations. And then if we follow this link, for example, we get information about when has the measurement been taken. So here we have a timestamp, and the result here is 11.15. And to interpret this, we go back to the data stream and see it's a PM10 concentration measured in microgram per cubic meter. So just to introduce you to this concept of having such APIs available and offering your real-time data through, for example, such a Sensor Things API has several advantages. So, for example, it's not yet done in data.europa.eu, but something which we are considering for the future as a potentially interesting extension. You could harvest such a Sensor Things API endpoint for available data streams. So based on this information which is available, you can interpret the data sets which are available and make these data sets accessible and discoverable via a catalog. So that's one aspect. And on the other hand, with these URLs and concept definitions of the standard, it's also quite easy to develop web applications on your own to consume data directly, to interpret it, to work with the data, and to make use of such a data set. So this is just a quick illustration. And of course, this is not enough time to introduce you into all the technical details of the standard. But what you could remember is there are already standards available for offering real-time data in a standardized way, which could be harvested in the future and which make it also easy for other developers to work with your data and consume the data into other applications. So that's the Sensor Things API. And the second thing I also would like to just quickly highlight is MQTT. MQTT stands for the Message Queuing Telemetry Transport Protocol. And basically that's a protocol coming from the world of the Internet of Things. So it's a protocol which allows to push data to data consumers. So the classical way, if you are downloading or accessing data on the web, is you send a request to some kind of web server, and the server processes your request and then gives back to you the requested data. With MQTT, you can have a different communication pattern because you can indicate at a server, in this case, a so-called broker, your interest in receiving certain information. That's called subscribe. So you are telling the server or the broker, I would like to receive all temperature measurements from a certain sensor as soon as they are available. And as soon as that broker receives this information from a corresponding sensor, it makes sure that it actively sends the data to your device, to your computer, for example, and that you get the data immediately as it is available. So if you are really wanting to minimize the delay and latency of data delivery, then protocols such as MQTT, which are widely accepted also in the Internet of Things community, may be suitable for you and maybe a good provide a good benefit in order to work with real-time data, making sure that real-time data is delivered as fast as possible to you. So one example here as a diagram. So on the left-hand side, we have different sensors, a thermometer, and two smart plugs providing energy to your devices at home. And these publish their data to a broker. So this blue box here is a so-called broker. The thermometer also publishes its information, and then, for example, here you as a computer can also connect to the broker, and you can subscribe, for example, to this plug number 1, so this one here, and subscribe all the data coming from this plug to get it immediately into your computer. There are already first MQTT brokers discoverable via data.europa.eu. Let me show this one quickly. So this is, for example, a big MQTT broker instance operated by the city of Hamburg here in Germany. And they are providing a lot of different, I would say, smart city information from all over the city via such a broker. And if you look here at the data set, what they provide here is IoT-Hamburg.de. That's the web address of the broker. And then you can take, for example, a small software tool. This is one desktop application. There are many other tools available on the market, open source tools. And then you can just enter this URL of this broker, and you can then connect to this broker. I will do this. And what happens now is we get our data. So the data is organized in so-called topics. In this case, you will find data streams. What's interesting here is they are using basically the MQTT broker in combination with the previous standard that we have shown, the Sensor Things API. So the data that you get via this broker is all structured according to this standard, so it can also be easily interpreted. And you see here in this short time, we have already received 1,800 messages plus, basically roughly 2,000 messages within these few moments coming from all over the city of Hamburg as real-time data streams. And then if we like, we can also try to interpret this further. For example, here we have a data stream available. I will try to copy this. I'm not sure if it works. Doesn't work. But basically, I will not try this too much now. But basically here, you get the information directly pushed into your computer. You get the latest observation data directly into your device and can easily interpret it because it follows the structure of the Sensor Things API standard. So this is just one further example of such MQTT-based, these are two examples that I have shown you, the Sensor Things API and MQTT, as protocols and standards for sharing geospatial information, real-time information, typically also associated with geospatial references, and make it available to users and make sure that it gets easily discoverable and reusable by external users. So this is just intended as a idea, some food for further thought. And if you are interested in this, we will also be happy to discuss this further with you subsequently after the workshop. So now the last part that we have planned is to go into a bit of discussion. We have to see how much time we have left now, how many of you can stay here. But before we go into discussion, perhaps also quickly checking with Antje if there are any questions on the two example technologies that I have shown.
There are some questions. First, there's a comment saying it indeed sounds interesting to offer these API via data.europa.eu. And then we have I'm not sure if this can actually be discussed, but there's a question or a suggestion of handling metadata for real time using a special property from data.apa called acroperiodity and frequency. I'm not sure if you can actually answer this right now, or if that's something for further discussion later on.
Yes, I think these are at least valuable parameters for indicating characteristics of the data set, and of course it can help to indicate real-time data sets. But it's still also perhaps something where we are further looking how to easily filter, perhaps by direct labels or something like that, data type definitions. But I think that's something we will definitively look further into.
Great. There's another question, and that's why are tools like the brokers displayed on data.europa as data sets?
This basically depends on how the metadata is also provided by the different organizations. So data.europa.eu doesn't create the metadata itself. It harvests them from existing catalogs. And so sometimes data providers want to publish their resources and package this somehow as a data set in order to make it discoverable. That's not ideal, but that's also something where we may look into the future, into providing better approaches to make it easier discoverable and better describable as dedicated resource types, for example.
That's it for the questions in the chat, and there are no new ones in Slido.
Okay, so then I would like to go into a discussion part. So unfortunately, we are running a bit behind our schedule due to the issues that we had with the provision of the link, but still, at least I would like to try to gather a bit feedback on a set of questions. And there I would like to ask you to go to Slido, and we will activate 4 questions that we would like to give to you. So the first question would be, which types of real-time data that you do not yet have access to would be most interesting for you? So it would be great if you could just, if you have an idea on this, put a short answer in the poll section on Slido. So just let me check. So if you go into polls, we have now opened this first question. And if you answer here and send, then that would help a lot. Perhaps it would also give us some indications how to approach data providers in the future, and or perhaps also motivate certain providers to share their data. So
Simon, are you sure you wanted that question or the next 4?
I also wanted this one. Oh, sorry. Yes, I didn't open the right one.
Yes, you have to.
I have to move ahead. Yes, sorry. Just one moment. I need to open the other window. Now it should work. So now the right question is open.
Thanks.
So we are getting the first answers. So energy and traffic has been mentioned. I think traffic is really something which is important for many people in their daily life as well. So I see energy, generation and consumption. So I think we will keep it open for roughly perhaps 1 minute and see if there's further input nuclear energy, car charger availability. Yes, car charger availability is indeed something very important if we want to support climate-friendly mobility. Construction blocked roads, that's also important traffic information. Weather data, yes. Energy consumption, fuel prices in different petrol stations. Indeed, that's also an interesting data set. And I think at least in some countries, there is data available. Taxi pooling, cool. Yeah, right. Okay. So with that, considering the time that we have, I would like to go to the next question. And this is perhaps a bit more complex to answer, but perhaps if you have any ideas or experiences, what are difficulties? If you want to use certain real-time data sets, are there specific difficulties? Have you already tried to search for real-time data via data.europa.eu? Did you use other means to search for such type of data? And which difficulties did you encounter? So I'm opening now the next poll. And again, it would be great if you could provide your feedback in there. Yes, so the first feedback, lack of standardized keywords, that's indeed something which is a bit critical. So also for me, I'm sometimes then searching for corresponding technology standard keywords, for example, but it's really something which needs to be improved by introducing dedicated functionality for this, perhaps. Also making sure that data is correctly described, so GeoJSON, not just as JSON to be described. Then the heterogeneity is mentioned. That's also a very good aspect. And yeah, heterogeneity in standards, how to express this, difficulties also getting this, so convenience, getting the data, for example, directly packaged as a handy app. Yes, the availability of data, search terms which are suitable. I think these are very good inputs for us also, perhaps to use this as a follow-up and perhaps start further discussions on this type of data and perhaps motivate people more to share also such data. Perhaps also some idea could be to provide more best practice guidance on the publication of such data sets so that we can establish perhaps more common keywords. Okay, so then, because the time is running, I will go for the next question of the poll. And the next question is, if you are aware of certain perhaps specific technologies that you consider important to deliver real-time data. So I have introduced here in the session today MQTT, Sensor Things API, the Fireware Context Broker as typical technologies which can be used for deliver real-time data. The question now is if there are further data sets, technologies that you would consider as important, which perhaps we should also have a look at as part of data.europa.eu to make these types of technologies for data delivery available. Perhaps that's a bit of a difficult question, so we have to see if there are answers on this. But if you have specific types of technologies, interfaces, standards, then we will be happy to consider this based on your feedback. WebSockets, that's very good, yes. So Web of Things, W3C, I think this can also relate to the OGC standards. So there's also some good exchange between these two worlds, but indeed, perhaps also something to follow up and have a closer look at. So we will definitively have a look at this. Yes, satellite data, that opens up a totally further a big field. So Earth observation data. And I think there has also been some activities to investigate how such sources of data can be integrated. Data brokers, LiDAR data, yes, that's also very good. Okay, so also here, quite useful and good feedback for our further discussions. And I will also shortly explain later on what we will also do with your feedback. And with that, I would like to go to the last question. So that's about this preview functionality that we have in data.europa.eu. I have demonstrated shortly that we have this preview for the bus locations or for the parking space availability. And let's assume that you have discovered a data set via data.europa.eu, a real-time data set. Are there certain kinds of preview that you would be interested in to further investigate if a certain discovered data set is suitable for you? So for example, it's such a map-based display that we have for the bus data or for the parking space is useful for you. Would you like to have an overview of the latest values, perhaps live diagrams? So if you have any ideas on further functionality that you would like to desire, then it would be great if you could put that now in slide into the last question that we have open. Temporal view and map view. That's good. So there may also be combinations of this. So for example, if we are looking at satellite data as a totally different type of data, then also there temporal maps would be something. Length of time series, very good. Refresh enabled by default on these different types. Yes, that's also good comment. Diagrams, yeah. So that's also very useful feedback and may also help us to further shape some directions and priorities of the development of support of real-time data. Location of sensor stations, I guess that's also very important, perhaps combined also with the feedback that length of time series would be interesting. So showing the availability of data for certain stations. The dashboard is mentioned. Okay, so with that, I would like to continue with the last part of our presentation. This would be just a quick view what will be next. So this shouldn't stand as an isolated activity. So as part of this webinar, we will develop a summary report describing on the one hand what we have discussed here, what we have presented, and on the other hand, summarizing also the feedback that we have received from you via Slidesoo. We would like to derive then also recommendations how data.europa.eu could be enhanced in the future for better supporting real-time data in the most useful way. And also perhaps recommendations, what could be a plan for data.europa in the EU in the future in terms of availability, reusability, and presentation of real-time information. So this is something which we will do as a follow-up to this webinar. And with that, perhaps just checking quickly back to Antje if there are any further open questions.
No questions in the chat or in Slido.
Okay, perfect. Then I would like to go to the last part, and we would like to get your feedback on this webinar. you can use this QR code to go to a feedback page, and you would help us if you could, give your feedback on this page in order to help us improving for future webinars. And with that, I would like to thank you for attending this webinar, and hope that you will perhaps join in one of the future Inspire data.europa.eu webinars, or also perhaps follow up on providing perhaps real-time data as open data sets in the future. And perhaps our short presentation may have given you some first ideas how to follow up this. And perhaps also, if you like, just get in touch with us, and we will also be happy to discuss any ideas with you. So thanks a lot for attending. And with that, we are closing the webinar now.